Give me 1 minute, okay? Physics R. Vivan, Siddharth, Moksha, Surabhi, Siddharth. Just a heads up, I want to ask Swarali and Moksha are not there in the classroom, right?
So I'm here
Swarali
online.
online. Okay. Keep your video on.
Yes, sir.
Swarali, keep your video on.
So 1 second.
Okay. So first is reflection. In reflection, you have to write three things: reflection by plane mirrors, then reflection by plane mirror, then reflection by concave mirror, and reflection by convex mirror. Okay. In reflection, right, there are first is reflection. In reflection, three things: plane mirror, concave mirror, and convex mirror. Okay. Written.
Sir, कैसे लिखना है सर? How should we write? Table format or?
ऐसे ही लिख दो रिफ्लेक्शन, उसमें देयर आर थ्री पार्ट्स. ओके.
Okay, sir.
ओके. ओके. उसके बाद ये हो जाएगा, रिफ्लेक्शन होगा, उसके बाद रिफ्रैक्शन आएगा. ठीक है. और रिफ्रैक्शन में सबसे रिफ्रैक्शन में होगा रिफ्रैक्शन थ्रू अ ग्लास स्लैब. सबसे पहले होगा रिफ्रैक्शन थ्रू अ ग्लास स्लैब. लिखो रिफ्रैक्शन थ्रू अ ग्लास स्लैब. Refraction through a glass slab, and then there is to TIR, total internal reflection, TIR. Okay. TIR. Okay. You have written TIR, everyone, and you show me thumbs up. Okay. Okay, good. And then you have refraction at spherical surface. Spherical surface will include everything: your lens, your spherical surfaces. Okay. Fine. Okay. In diffractionate spherical surface, you have this thing called lens maker formula. Okay, you have lens maker formula. This you have to do. Okay, iska derivation comes up in exams. Okay. Okay. Then you have, this is again a lens thing, so don't write it. Combination of lenses again, lens thing, don't write. And then you have refraction through a prism. So basically you have refraction through three things. First is through a plane surface, second is through spherical surface, and third is through prism. Okay, refraction through a prism. This is also important. Okay, now technically in grade 10th you have read everything before 9.6 but TIR, except TIR you have read everything. Okay, so we are still going to do a small revision of all that. Okay, लेंस यहाँ इसके पहले लेंस मेकर से पावर ऑफ लेंस एक मिनट. Yeah, you have done all this before this, not this. Yeah, before TIR you have done all this, not refraction, this all you have done, right? ये सब कुछ concave mirror, convex mirror, 1 by V 1 by U, okay, is equal to 1 by F. We'll still do it. Okay, but
Thank
if
you.
everyone knows it, we will do it fast. If you have doubt there, we will do it slow. Okay, so I want you to okay, then you have two things very important. Prism के बाद optical instrument में there is a microscope, which is a big thing, and then there is a small thing called telescope. Okay, so write optical microscope, optical instruments, microscope and telescope. Write this: optical instruments, microscope and telescope. Okay, microscope and telescope. Yeah, this इसके बाद chapter over है. ठीक है. Okay, so in the first class we are going to do today a small revision of whatever was there in 10th grade. Okay, but the reflection only, not the refraction. So we'll not go into lenses, we'll only go till mirrors, curved mirrors, plane mirrors, convex, concave. And after you go home today, after this class, you have to do this 10th grade worksheet, so that you know, I know you are abridged with 10. Okay, you have to do this necessarily and come tomorrow. Okay, this worksheet is this worksheet, it is there on the website, but I'll give you the link. Okay,
Sir, small issues, sir.
small
Issue.
yeah.
I don't remember anything from 10th.
Oh, you don't remember anything. ठीक है. Okay, good that you pointed out. So I will आज बताता हूँ, उसके बाद कर देना. ठीक है, देखना आज बता देता हूँ. एक मिनट पहले मैं I'll give you the link. Okay,
Okay, sir.
आज फिर सिर्फ रिफ्लेक्शन करवाता हूँ, तो रिफ्लेक्शन वाला पार्ट करना. ठीक है, देख लो. द रिफ्लेक्शन पार्ट इज फर्स्ट 2 pages ऑफ द वर्कशीट. लिखो, मैंने तो पूछोगे मेरे से बाद में कितना करना है. रिफ्लेक्शन पार्ट इज फर्स्ट 2 pages ऑफ द वर्कशीट. ओके, उतना ही करना है आज. And the worksheet is, I'm sending the link in the group. Okay, and okay, 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 I've sent the link in the group. You have to do this worksheet. Okay, and first 2 pages only you have to do after today. I will only teach mirrors today, mirrors. Okay, so for I will tell you how ray diagrams work, and then I'll tell you the formula. Okay, and after that you can solve the numericals, these numericals which are given in the this chapter. Okay, if you have a doubt in something like conceptually, you can see the video. It is there on the उसी assignment से ऊपर link है video का. You can see the video, or better what you do is you ask me, this part is I'm having doubt, I'm not understanding magnification. I'll tell you what exactly to watch, which 10 minutes exactly to watch. Okay, fine. Ping me with your question, I'll reply. Okay, okay. First things first, I'll tell you the basics of reflection. Okay, sign convention, then you have reflection, mirror equation, derivation of mirror equation. Okay, fine. See, Okay. Oh, my screen is not visible. One second. Can you guys now see my screen?
Yes, sir.
Okay. So, see, first of all, you should understand light. In this chapter, so this is one very important thing. In ray optics chapter, light is treated as a particle, okay? In ray optics chapter, light is treated as a particle. And this is chapter number 9, right? Chapter 9. And then, right? Is that correct? Chapter number 9, and then chapter number 10 is called wave optics. In wave optics, light is treated as a wave, okay? So, in this chapter number 9, that there are two basic properties of so light particle. Like if you treat light as a particle, there are few basic properties upon which the whole chapter is built up, okay? Very few basic properties. The few basic properties are number one is Fermat's principle. Okay, and Fermat's principle पे based है, and then Fermat's principle, Snell's law of reflection, then law of reflection, third is law of refraction. And I think this much is pretty, these three laws pe, and even these two laws are somehow based on this law, okay? So this is the most important law. It is not mentioned in your book, but the result of these two laws, this law, which is number 2 and number 3, are mentioned in your book, okay? The Fermat's principle is saying that it is very simple, that if light has to go from point A to point B, it will always take the shortest time path. It is always the shortest time path, okay? It's very basic law. If light travels from point A to point B, it is always shortest time path, okay? And you have to write, it is not necessarily shortest distance path, okay? It is not always shortest distance path. Usually it is shortest distance also in general. If you have to go from point A to point B, usually the shortest distance path is the shortest time path. But the concept is that it's shortest time path. Sometimes it is not shortest distance, okay? Fine. And the second, so this is the first thing, Fermat's principle. And the second thing, which is more basic, is that speed of light. So speed of light is constant, okay? It is constant, okay? And it is 3 into 10 to the power 8 meter per second. Approximate value hai. The exact value is some 2.99725 aise kuch hai, but for all good reasons, you have to remember this, okay? Speed of light is constant. It is 3 into 10 power 8 meter per second. Fine. And the speed is pretty huge, okay? And this is also the maximum speed of anything. And it is also frame independent. What is the meaning of frame independent is, see, for the meaning of frame independent, if you have a car, let's say you have a car, it is going at 5 meter per second, okay? Car A is going at 5 meter per second and car B is going with 10 meter per second. So an observer, so this red observer who is on ground, what is the speed of A with respect to the red observer? Answer, jaldi bolo. कितना है? 5, right? Yes or no? Speed of A with respect to R is 5 meter per second, correct? ठीक, second बताओ, speed of B with respect to R is equal to कितना है?
10 meter per second.
And
10, right? 10 meter per second. Okay. Next question. Speed of B with respect to A कितना है?
5.
5, right? So this is all okay. Okay. Now, this is, so do you understand that speed of B with respect to A and B with respect to red is different? Because if the observer is on ground, he's seeing the speed of B as 10. But if the observer is on A, yes, he's reporting the speed of B to be 5, right? This is true for general cases, but what if this thing is going with, let's say, okay, actually, by the way, if you have a car C which is going like this and its speed is, let's say, 20 meter per second, my question is, what is the speed of C with respect to A? What is the answer? 25. ये समझ में आ रहा है ना? This is 25. Yes or no? Everyone is getting this. This is 25 to the right. Okay. Now see, consider this case. A spaceship A, spaceship B. Now this is going at, let's suppose if this is going at 0.6 the times of light. Okay. So it is 0.6 times C, which is, so this, if this value is C, 3 into 10 power 8 meter per second is C, it is 0.6 times of that. Okay. Okay. And if B is going to the right, again with 0.6 C, what is the speed of B with respect to A? What you should answer? 1.2 C, right? But the moment you say 1.2 C, ये 1.2 बड़ा है ना 1 से, so the speed is greater than the speed of light, right? Yes or no? So this won't happen. So this can't happen. Like 1.2 से नहीं जाएगा वो. Okay. Okay. So nothing can cross the speed of light. This is a constant, and this is a constant, and it remains so. It is always frame in. This is the meaning of frame independent. Okay. Speed of light can't be changed. So even if your observer sitting here and there, okay, the speed of light is always same. Okay, fine. Okay, now the first law is law of reflection. We're going to do reflection today. So we are going to do reflection, and reflection is simple. First thing, there are two laws of reflection. First you have to understand what is a tangent, what is a normal. You already have done in maths how to find a tangent of something, right? So if y is equal to fx, and then its function is like this, then you find the derivative at that point, right? At this point, if you want to find the tangent at this point, you find the derivative at this point, this tangent, right? Understood? And then if you want to find the normal, you find a line which is perpendicular. Slope of tangent into slope of normal is equal to -1. So you'll get the normal as this. Okay, understood? Fine. So this is what a normal is. Okay. And just right, you will be dealing with plane surfaces, either plane surfaces or circular curved. Okay, part of a circle. So you should understand that in a plane surface, if this is a plane surface, the normal is a line perpendicular to it. Pretty simple in a plane surface, right? So if you want to find normal at point A, the normal at point A is this. Okay, if you want to find the normal at point B, it is this. Fine, understood? It is pretty clear, right?
Yes.
For a circle, circle, you should understand that at this point, the tangent is looking like this, right? And the normal, write it. Normal is a line which is passing through the center also. So it always passes through the center. So it is the radius basically. The radius is the normal. Okay. In a circle, radius is the normal. The radius connects. You write it. Okay. It may be seeming obvious now. When you're solving numericals, it won't be. So write this. Write this. In a circle, the radius is the normal, and radius passes through the center of the circle. Okay. Radius passes through the center of the circle. This is the center of the circle. Okay. Fine. So this is how normal is defined. Okay. Yeah. Okay. So there is laws of reflection. There are two laws. First law is write the normal, the incident ray and the reflected ray lie on the same plane. I'll read it out in case this bad handwriting. The normal, comma, the incident ray and the reflected ray lie on the same plane. Okay. And the second law is angle I equal to angle R. The angle of incidence is equal to angle of reflection. I am explaining both of them. If you have, so suppose there is a surface like this, okay, and your incident light hits at this point P. So first you make the normal at P, which will look like this. Normal look like this, okay. The incident ray is a light ray which comes to the point P, okay. So this is the incident ray. I'm calling it IR, okay, incident ray. The light is coming like this, okay. Yeah. This is called angle of incidence, angle I. Angle of incidence is the angle between the incident ray and the normal ray. Then there is something called reflected. So this ray will be reflected like this. And that ray I'm calling RR, reflected ray. And this angle between the reflected ray and the normal is R. And the formula says, so there are two things which first law says the blue line, the red line, and the black line, they lie on the same plane, okay? Right now they are in plane of the paper in which I'm writing. Okay. The second law says I equal to R. Okay. Though both these angles are same. Okay. So therefore, you can just do some questions with respect to this. So hello, yes. Is anyone asking something? Okay. So a few questions on this. Let's say this is a plane. Okay. If a light ray is falling like this and this angle is 60 degrees, what is theta? What is theta? Question number 1. Yeah, Amit. Amit. 60. What is angle theta 60 called? हाँ? कोई 30 बोल रहा है क्या? देखो 60. This is 60, but this is not angle of incidence. Angle of incidence will be normal के साथ 30 होगा, okay? And therefore the angle of reflection is also 30, and therefore this angle is 60, okay? Fine. Everyone has understood this. If you have not understood, raise hand, okay? Everyone is okay with this? Fine. Question number 2. Mirror 1. This is mirror 1. And then there is mirror 2. Both are perpendicular to each other. M2. M2. Now there is a light ray which is coming perpendicular. Both are perpendicular. Okay. Light ray which is coming at, let's say, angle. You can say any angle theta. Show that after second reflection, it goes back parallel. Okay. You have to show that after second reflection, it goes back parallel. Show this. Do this.
Like, do we have to like somehow calculate it, or should we just draw it?
You draw in the sense you make the diagram and then you show the angles and then show that you have to.
Do
By
it.
the geometric property, you should be able to prove that the line which is reflected afterwards, show that after second reflection, it goes back parallel.
Okay.
Darsh, what is angle 1 equal to?
Theta,
Angle 2,
90 minus theta,
angle 3,
theta,
angle 4,
90 minus theta,
angle 5.
90 minus theta,
Pardon?
90 minus theta.
Good. 90 minus theta. Okay. Now, if you see in hello, yeah. If you see the line AB and the line CD, line AB and CD, you can treat the BC to be like a transversal, and you can see that this angle. So now, if two lines are like this, and this is like this, and if these two angles sum add to be 180, then the black lines are parallel, right? Right? If these two angles sum up to be 180. Now see here, these two, what is the sum of these two angles? Blue. What is this whole angle? 2 theta, right? And what is the sum of this? 2 times of 90 minus theta, right? So the upper wala ka sum hai 2 theta, niche wala ka sum hai 2 times of 90 minus theta, right? So what is their sum? Therefore their sum is 180. So therefore AB and CD are always parallel, irrespective of whatever is theta. Fine. Okay, write this. Everyone has understood this? Moksha and Vansh, keep your camera properly. Okay, okay, so this is done. Reflection mein, okay. Now also there is a concept called concept of like show that, right? Show that the minimum height of mirror required to see my full body image is half of my body height. Okay, half of my body height, right? Show that the minimum height of mirror required to see my full body image is half of my body height. So for example, if you're standing in front of a mirror, okay, and let's say your height is 1 meter, 100 centimeter, okay. So if you see, if you have a small mirror, 10 centimeter mirror, so and if you go enough far from it, you will not be able to see yourself, okay. So you can try this out. So you will be able to see your full body image only if the mirror height is at least 50 centimeter, okay, half of your body height, okay. we can show this, we can prove this result by saying this. Okay, so let's say, so try to understand how what happens. So suppose this is a human body. Okay, and let's say for argument purposes that eyes are here. Okay, because I need some space. Okay, now these are eyes. Okay, and this is a mirror in front of you. So this is a very long mirror. I will just see what part of it minimum I need. Okay, what part I need. See, you should understand how reflection works. Reflection works. Suppose you have something on your knees. Okay, you want to see a knee portion. How will you be able to see it? See, a light ray will go like this. So see, from point, many light rays, right? So a light ray will go like this, right? A light ray will go like this, light ray. So, because the light source doesn't know that you have kept a mirror, right? So it just emanates lights in all directions. Okay. The thing is that which will reach your eye, that light ray which reaches eye such that, this will reach your eye such that, do you understand this I is equal to R, right? Yes or no? This will reach. Probably if I am giving A, B, C, D, F, only D will reach. C is not going to reach, B is not going to reach, E will go above your head, right? Above your eyes. F is also going above your eye. Understood. Now, if you try to, in general, if a point is here, and then, if you make it here, point P dash, then this triangle becomes congruent. Congruent in the sense because this is same, this is same, this is 90, 90. You can say by RHS also, you can say by ASA also, you can say by SAS also. By all, it is same. So therefore, the important thing is that these two distances become equal. Okay, from the midpoint to the knee. Okay, so therefore, let's say out of total height h, your x portion is above your height I, and y portion is below your eye. So such that x plus y is equal to h. If you want to see the lowermost point, right? The lowermost points of the light ray will hit like this, and then it will hit your eye, such that this triangle is, this is the midpoint, right? And this distance is by 2. Do you understand this, everyone? Yes or no? Therefore, do you understand that only this mirror? So, if if you need a if you need a light ray from this point, the lowermost point, you need this black ray, right? If you need a light ray from a point above the point, you will need something like this. Okay, something like this. So you need a portion of mirror above this point, not below this point, right? You don't need a point of mirror below this point. Do you understand? Yes or no? Similarly, symmetrically, you can say that topmost point जो है उसका light ray will go like this. So midpoint उसका यहाँ पे आएगा, and this point of the mirror, and this point x by 2, and you don't need any mirror which is above this point, upper point, and you don't need any mirror which is lower this point. Okay, understood? So only this part of mirror is required. And what is this part? The upper portion is x by 2, the lower portion is y by 2. So this is total x plus y by 2, which is equal to h by 2. Okay, so only this part of mirror is required. Understood, everyone? Fine. So basically the mirror which is required is above your eye level, whatever is your height, body height, that by 2, plus whatever is your height below your eye level, that by 2. Okay, which is effectively your height, total body height by 2. Fine. Quickly write this, giving you 2 minutes. Write the logic also. Okay. When you're done, let me know. Okay.
Done, sir.
Okay.
Sir, does it, what will be the distance from the mirror?
It doesn't matter. This, okay, good question. This doesn't matter. You're asking this distance, right? The green.
Yes, sir.
It doesn't matter. If this is fixed. This is the minimum height required. Okay. If the mirror is more than 50 centimeter, halfway right, then also you'll be able to see. Okay.
Okay, sir.
Okay. Next thing is what happens when you have a curved surface. Okay. Plane surface is easy. Okay. You should also understand how an image is made. Okay. How do you able to see images? What is a virtual image? What is a real image? See, suppose there is some object kept here, okay, in front of a plane mirror. So there is an object, okay, and it's kept in front of a plane mirror. There is a plane mirror. Object is kept here, okay. See, you should understand one thing. Just because there is a plane mirror, the object light will not change. It will always, object always emits lights in all direction. It will emit light in all direction, okay. The object doesn't know that there is a mirror. Light is emitted in all directions equally, right? This was happening before you kept the mirror. Now, when you kept the mirror, what happens? Some of these light rays, for example, this ray, A, B, C, D, all these will start deflecting, right? They'll start reflecting. So what happens? B and C. So let's say I pick up C and D, okay? So the C and D, C will be reflected like this, right? And D will be reflected like this. Sorry, D is like this, so it goes like it's fine. Okay, okay, fine. This is also true. This is happening. Okay. Now, what happens? What interesting thing happens when you try to look at this? Our eyes are made such that if they see a diverging ray, our evolution is such that if they see a diverging rays, they try to they try to trace it backwards and they make an image out of it. When you say make an image out of it, they try to see the perception of it. Okay. So we see a perception of this. So if you keep an eye here, if you start looking here, okay, like this is your face and this is your eye, okay. What happens is these two, so on a smaller scale, okay, there will be two rays. So actually what will happen, there will be not these two very far off rays, but those two. So basically actually red one is actually like this. Sorry. Actually, those rays which were about to hit the eyeball, only those two rays, okay, they're slightly diverging from each other, but they're hitting the eyeball, okay. These two rays will be back produced like this. So right now I'm just explaining it with these two lines, not original lines, okay, because the triangle will be difficult to make. So understand it geometrically that these two rays will be produced backwards, okay, fine. Blue one will also be produced backwards, and this is called the virtual image. Okay. So understand that there is no there is no candle at the back of the mirror, okay. There's nothing like it is not does not exist there. What happens is because you're trying to see, you are seeing a candle or a block behind the mirror, okay, fine, understood. If you don't see it, it's not there. Very simple. Okay. That's why it's called a virtual image. It does not exist in real. So virtual, it's like virtual world. Okay, fine.
So what about the like ray directly from one to like the
From
virtual image to the
from the object to the eye,
an object to the virtual image?
ray directly from the object to the virtual image.
Yeah, without any.
Like ऐसे ये वाला,
Yes, sir.
ये वाला ऐसे चला जाता है, मतलब समझा नहीं, मतलब what is the question?
In the form of virtual image, like we saw an angle diverging. Like I mean, like
नहीं देखा, अच्छा सुनो सुनो, एक डाउट, एक ये सुनो, अगर इफ यू आर डायरेक्टली सीइंग दिस ऑब्जेक्ट, ओके, हाउ डू वी
yes, sir.
डायरेक्टली see some object? सेम है, two rays which are coming slightly diverging, what we do is our eyes try to form it, and you know, मतलब आई मीन वहां पे तो सी ऑब्जेक्ट से आ रही है ना, तो यहीं पे दिखता है, यहीं पे इमेज दिखता है कि ऑब्जेक्ट है यहाँ पे, ओके।
Yes, sir.
सो सेम थिंग व्हाट हैपेंस, दिस देखो, ये रे 1 और 2 है, ठीक है, ये तुम्हारे पास डायरेक्टली आ रही है, फिर ये सर नो,
Yes, sir.
तुम, लेकिन दे आर डाइवर्जिंग, राइट?
A bit.
You are seeing the object directly, understood?
Yes, sir.
Same when these two rays, so on a, you know, if this was your eyeball, this 1 and 2 was coming, you will see the object here, right? Yes or no?
Yes, sir. Yes, sir.
From your reality hands and touching and all, you know that object is not, you know the mirror hai, so there is a reflection, we call that reflection. Okay, we call it, it's a virtual image, right? Otherwise, if you don't know the reality of it, your eyes won't be able to differentiate whether it's an object or an image. Okay.
Yes, sir.
Okay.
Yes, sir.
Thing. Okay, fine. Okay. Okay, this is how, so there is a, in a proper, there is a sign convention now. Sign convention means if this is a mirror, like, okay, then this is axis, and then there's first quadrant, second quadrant, third quadrant, fourth quadrant. Very simple. Anything, if you measure to the right, it's positive. If left is negative, up is positive, and down is negative. Okay, quickly write this. Okay. Girls, you want to sleep, go home and sleep. Okay, sit properly. First, second, third, fourth, positive, negative, up, right positive, up positive, left negative, down negative. Okay. Okay. Now, ये हो गया ना? Okay. Okay, cool. Now, negative. And right, all distances are measured from the pole. All distances are measured from the pole. Okay. Object distance is called U. इतना तो याद है ना वंश? कि भी भूल गया.
Oh, sir. I'm confused between U and V.
Oh, U comes before V, right?
Yes.
Object comes before image. If there was no object, there was no image.
Okay, sir.
Okay. Okay. Now in plane mirrors, U is equal to minus V. You understand why U is equal to minus V? Because in a plane mirror, if you keep the object here, the image is here, right? If this is 10 centimeter, this 10 centimeter again, but because this is 10, you'll write this is minus 10, right? So U will be minus 10. You understand? And V will be plus 10. किसी को doubt है इसमें? नहीं है ना doubt? तो equation ये है, U equal to minus V. Okay, everyone? Fine.
Yes, sir.
Something called M is equal to height of image by height of object. This is also plus 1 here, okay? Because the height of image and height of object are same. So in plane mirrors, M is equal to 1 and U is equal to minus V. Okay, these are the two equations of plane mirror. So Raleigh, you're not writing.
So how will the plane mirror form a virtual?
How the plane you're saying how the plane mirror forms a virtual image. Hmm?
Yes, sir.
ये प्लेन मिरर ही वर्चुअल इमेज तो बना है, मैं समझा नहीं, ये जो केस था डिस्कस किया, इसमें प्लेन मिरर है, वो वर्चुअल इमेज ही तो बना रहा है. यू स्टिल हैव अ क्वेश्चन? नहीं, ठीक है. वर्चुअल इमेज के बारे में ये है इंपॉर्टेंट थिंग कि इट इज देयर बिकॉज यू आर ट्राइंग टू सी इट. इफ यू डोंट ट्राई टू सी इट इज नॉट देयर. ओके, real image is there whether you are seeing it or not, it is always there. Okay, if there is a real image at a point, it is there. Okay, fine. Okay, uh, you write about real image example, लिख लो real image का. Image का ऐसा है, suppose you are using a convex lens and you are trying to, you know, you are trying to see the sun. Okay, see the sun मतलब you are trying to focus the light rays of the sun. What happens, sun rays से light rays are coming parallel almost, convex lens से focus पे बनता है, यहाँ पे एक sun बन जाता है छोटा सा. ठीक है, and then what happens, this is a real image. Okay, and if you keep a paper here, it will actually burn. Okay, everything is, so even if you don't keep the paper, this place is hot. Okay, so it's not because you kept the paper it is hot, it is anyway hot. Okay, fine. Okay, this is a real image, and real images are always inverted, inverted with respect to object. Okay, and virtual are always erect. Okay, fine. We will do there is a derivation called, okay, understood. Real images are always inverted, virtual are always erect. Okay, next thing is for a concave mirror and convex mirror. So the thing is, if you take a circle, okay, and then you cut some part of it, so here there is a circle. By the way, what is this point called? Do you remember? Hello.
Center of a circle.
Very good. Center of a circle in maths. Center of circle in maths. In this chapter, it is center of curvature. It is not called the optic center. Okay, center of curvature. And then what you do is you take some part of it. Let's say you take this part of it. So between these two red parts. Okay. Okay. You have to understand that this is this is basically a sphere. Okay, it is a sphere. It is not a circle. Circle is a two-dimensional object. We're talking of three-dimensional object. Even if I have said circle, I have said wrong. So this is not circle नहीं है, ये actually sphere है. ठीक है, sphere है and center of curvature. Okay, so you should understand that this is like, you know, you can like this. So it is not a C. It is not like this. See my hands. It is not like this. If you see, it is something like this. Okay, from the front. Okay, like this. Okay, everyone. Okay, ऐसा है ना वो?
Yes, sir.
ठीक. Okay. Now, if you polish this side, what do you get? If you polish the red side, what do you get? Which mirror do you get? देखो देख पॉलिश अगर इधर हो रहा है ना, अगर अंदर पॉलिश हुआ तो बाहर का साइड रिफ्लेक्शन हो जाएगा. अगर ऐसे पॉलिश हुआ तो रिफ्लेक्टिंग साइड कौन सी होगी? आउटसाइड. And then you will get a convex. Okay, right, you will get a convex. Okay, and if you polish on the outside, then the inside part will become reflective and that will be concave. Okay, okay everyone. In either of cases, the normal is always passing through the center. Okay, doesn't matter. So let's say I'm taking an example of a concave mirror. Okay, so I'm making concave mirror, and you should understand that this is center of curvature and this is called pole of the mirror. Pole of the mirror, yeah, pole of the lens. No, pole of the mirror, okay. Pole of the mirror, this is center of curvature, and the basic formula is, if you, okay, so there is a point F, and F is in midpoint, F is the focus, and it is in between the midpoint. We will discuss more about it. It is not always midpoint, but we'll discuss that in the next class, okay. So for your syllabus, it is in midpoint, okay, and a light ray which is coming parallel to the principal axis. By the way, this is principal axis, okay, this line. ये सब याद है सबको? This line which comes parallel to the principal will pass through the focus, right? This is number one. Number two, any light which is passing through the center of curvature. So if it is passing through center of curvature, so you should understand that if it's passing through center of curvature, then the normal will also pass through C, because, right? So therefore, the I will be 0, because the incident ray itself is the normal. Therefore, R will also be 0. Therefore, for the, it will go like back on its same path. Okay. So if you have a light ray coming from C, it will go back to the same path. And the third ray, which, one second. Yeah. So I write these three statements. Light passing parallel to principal axis will pass through the focus. Quickly write. Light passing through parallel of principal axis will pass through the focus. Second, light passing through center of curvature will go back undeviated. First statement written. Second is of light passing through center of curvature will go back undeviated.
So, so can you repeat once?
First is a ray passing through principal axis will pass through the focus. First हो गया. Second is a ray passing through focus. Second is a ray passing through center of curvature will go back undeviated or go back on its same path. Okay. Third is a ray passing through focus will go parallel to the principal axis. Okay. Using these three statements, there is a derivation which we are going to do tomorrow. Okay. Okay, but before tomorrow, I'm anyway giving you the formula of the derivation. The formula is 1 by v plus 1 by u is 1 by f. Okay, this is the formula. And where v is the image distance, u is the object distance, and f is the focal length of the lens. Focal length, and it's always r by 2. So if radius of curvature is given, it is r by 2. If directly, sometimes focal length is given. You should always also understand the focal length of a convex mirror is positive. Okay, and for a concave, it is negative. Okay, focal length. So f, write this. Okay, very important. Don't forget. For a convex mirror, it is positive. For a concave mirror, it is negative. Okay. Hello. Convex is more than 0, concave is less than 0. Okay. Next, there's one more formula. This formula is m equal to hi by ho. Okay. I've written this in black, okay, because it is always true, whether it is mirror or lenses. So we are right now doing mirrors, right? So the black thing is always there. The blue thing is minus v by u. It is only for mirrors, okay? So write this. This is always true, whereas this whole thing is for mirrors only. Okay, this also for mirrors only, for mirrors only. By the way, therefore this should be written in black, because f, this is also true for both mirrors and lenses. True for both mirrors and lenses. Okay, true for both mirrors and lenses. Okay. Okay. सिद्धार्थ, एक कॉन्वेक्स लेंस है, उसका फोकल लेंथ पॉजिटिव है कि नेगेटिव है? सुनाई नहीं दिया, पॉजिटिव है नेगेटिव? 1 minute. पॉजिटिव, अच्छा. और सूर्यतेज कॉनकेव मिरर है, उसका फोकल लेंथ क्या है? पार्डन? ठीक है. ठीक है, ओके फाइन. तो एक क्वेश्चन ऐसे आता है, फॉर एग्जांपल क्वेश्चन ऐसा आता है कि लेट्स से देयर इज अ कॉनकेव मिरर, let's say there is a concave mirror whose focal length is 20 centimeter. Automatically, whenever you say concave mirror, focal length is 20 centimeter. Therefore, f is actually equal to minus 20. Okay, it's a mirror, concave mirror. Okay, so f is minus 20, and an object is kept at, let's say, distance u is equal to 40. Okay, the object is always kept to the left, so u will be plus 40 or minus 40.
-40.
-40 अब डाल दो फॉर्मूले में, फाइंड v and m. Okay, find it quickly. Okay, have you guys got it? V is equal to, yeah,
-40.
-40 centimeter, yes, and m is equal to
1.
na
-1.
-1. So therefore the image is, see, the moment you have m equal to -1, that means the hi by ho was equal to -1. Therefore hi is equal to -ho, right? That means height of object is negative height of object. Negative height of object. Height of image is negative height of object. Therefore, images, if the object is upright, the image is like down, okay? And the distance of image is how much? 40. So therefore, the image is like this. Okay. Fine. Everyone? You are asking me something, Darsh? Speak.
Yeah, is this place that radius information?
It is. Are you asking that? Does it mean it is at center of curvature? C.
Yes.
Yeah, it is at center of curvature. The object is kept at center of curvature because the center of curvature is double the focus. Okay. Okay, everyone. One more do you do? For the same f is -20 concave mirror, find if u is -30 centimeter. What is v and what is m? What is v and what is m? Guys, done with it? V कितना आ रहा है?
-60.
-60. And M is equal to?
-2.
M is -2. -2, right? Therefore, the image, the diagram will be looking something like this. So your object is at, so F, and then you have C. Object is at -30 somewhere here, and the magnification is -2, minus, so it is down, reverse, okay, and it is 60, so it is 30. 30 से डबल डिस्टेंस पे यहाँ पर है कहीं पे, और ऐसे है, ठीक है, अंडरस्टूड? ओके, is a real or a virtual image? Real. It is inverted, so it is real. Okay, fine. Okay, ठीक है बस.
Sir, I didn't get.
क्या कि which part पूरा बोलो, क्या नहीं आया?
So this part, so like this the current sum.
V आ गया.
Yes, sir, V I got.
V u -60 you got. M you got -2.
So M I didn't get.
M is formula है HI by HO is equal to -V by U.
Okay, okay.
Okay, so therefore M is -2.
Yes, sir.
M is -2 means the HI by HO is -2.
Okay.
So that means HI is -2 times -2
HO.
times HO. So it is twice the size, and negative means it is okay.
Inverted.
Yeah, inverted. So therefore, do you understand? And the distance is 60 you got, no?
Yes, sir.
क्योंकि दूर है, माइनस लेफ्ट में है, -60 मतलब माइनस मतलब लेफ्ट में है, right? 60
Yes, sir.
60 डिस्टेंस है. Understood?
Yes, sir.
Fine. You do, everyone do the questions, first 2-page questions which are there, I have sent, okay, in the group. Okay, first 2-page questions. Okay, bye bye everyone.